Hi everyone, Miss Meek here, and today we're going to talk about multiplying and dividing equations. Multiplying and dividing equations. Specifically, we're going to talk about how to solve them. So how to solve multiplying and dividing equations. We're going to talk about some modeling. We're going to talk about what happens if we're given fractions or decimals, things like that as well, because there are a specific way that you can handle those types of situations. We're also going to talk about how we can use the property of equalities to solve these equations, just like how we did in an earlier video when we talked about that in adding and subtracting equations. So let's go ahead and get started. The first thing we're going to go over is some modeling. We can show these equations using a tape diagram. A tape diagram is a rectangle that shows how much you have. It also shows the total down here at the bottom. So this is the total. What this tells me is that I have 1, 2, 3 x's, and together they all equal 12. So what does each x need to be in order to equal 12? Well, each x needs to be a 4. 4, 4, 4. That would all add up to 12. We can also use a picture, just a picture model. Here I have 2x, and it says that those 2 x's equal 6. So that would be my equation. So how much does each x need to be? Well, if each x was 3 boxes, it would match what we have on the other side of our equation. So x needs to be 3 ones. That is the whole purpose of solving equations, is to get one side of the equation to match the other side of the equation. That is the whole purpose in solving equations. That's why here in a minute we're going to use the property of equality, because our whole job is to get one side to equal the other side. Okay. The third way that we can model these types of equations is with a hanger model or a mobile model. On this side of my equation, I have 1, 2, 3, 4, 5, 6, 7, 8. And if this side equals 8, that means that this side also is supposed to equal 8. For this hanger to be balanced correctly and not be slanty one way or the other, each side has to equal the same thing. And so that makes my equation be 4x needs to equal 8. Well, then how much does each x need to be? In order to make that happen, each x needs to be 2 circles, and those circles are represent 1. So that means x needs to be 2. So if each of these was a 2, then we would be able to add up to the 8 that we need. But what if we can't draw a model, or what if it's just that's not what we have to do? Well, there is a way to solve these. Again, just like with addition and subtraction equations, we want to do the opposite operation to solve these. We want to use the inverse operation in order to solve these equations. So if I am multiplying in my equation like I am here on number 1, what I would like to do to solve this is to divide. So I am going to divide by 3 on both sides. My whole goal is to get the variable, the letter, by itself, because I want to know what it equals. I don't want to know what 3 g's equal. I want to know what 1 g equals. When I do this, these 3's are going to cancel, leaving me g all alone. Great. And then if I do that to one side, I have to do it to the other. So 27 divided by 3 is 9. Plug it back in to make sure that that works. Is 3 times 9 27? Yes, it is. So I have solved this correctly. On number 2, we have an equation that's having us divide by 6. Remember, this is the algebraic way of writing dividing by 6. To undo division, I am going to multiply both sides of my equation by 6. I am going to multiply both sides of my equation by 6. When I do that, it is going to cancel the 6's over here and leave k by itself. How did it do that, you may ask? Well, when I multiply by 6, that's actually 6 over 1. And so when I go to multiply this, I get 6k over 6. Well, remember, 6 over 6, that simplifies down to 1, okay? And so I am left with that 1k. And then on the other side, I'm doing 24 times 6. 24 times 6, let me work that out real quick so I don't make any mistakes there. And that is 144. Now, if I go and I plug this in, is 144 divided by 6 24? Yes, it is. And so I know that I have done everything correctly when I go and I plug in that K into my problem and make sure that it works correctly. On number 3 here, this is another division problem. So I am going to multiply both sides times 2. When I do that, these 2's are going to cancel down to 1 and leave n all by itself. And then 10 times 2 is 20. Plug this back in. Is 20 divided by 2 10? Yes, it is. So I know that I did this correctly. And on this last one here, I am multiplying by 9. So that means I'm going to divide by 9 on both sides. When I do that, these 9's are going to cancel down to 1. And I'm left with n, which is great. That's what I want. I want to know what n equals. I don't want to know what 9n equals. I want to know what n, 1n equals. And when I finish solving this, 63 divided by 9 is 7. I can plug that back in. Is 7 times 9 63? Yes, it is. So I know that I did that correctly. So we're using the inverse operation, which means the opposite operation to solve these. If I see subtract, or if I see multiplication, I'm using division. If I see division, I'm using multiplication. We're undoing what is happening here. Now, what happens though when you get a fraction in your problem? Okay, that kind of stirs the pot a little bit there. So when we get a fraction, what we want to do is we want to use the reciprocal. We want to multiply by the reciprocal, because remember, our whole goal is to get this variable over here by itself. And so to get this fraction to go away, I have to multiply by the reciprocal. So what does that look like? Well, that means that I'm going to multiply each side of my equation by 4 over 1 for this first problem. My fraction is 1 over 4. The reciprocal is when we inverse that fraction, so flip it over. And so I am going to be multiplying by 4 over 1. What that does, when I multiply straight across here, I get 4 over 4x. And as we know, this 4 over 4 here equals 1. And so essentially it cancels down to 1, and I'm only left with x, which is what we want to see there. So these will cancel out and leave me with x, okay? They'll leave me with 1x. And then over here on the other side, I'll put this whole number over 1, and we will multiply straight across, and I get 44 over 1, which is the same as 44. And we're done. So you're multiplying by the fraction flipped upside down. So on number 6 here, 2/5 b equals 20. I'm going to be multiplying by 5 over 2. When I do that, what it gives me is it gives me 10 over 10 b. And again, this 10 over 10 here, it equals 1. So they're canceling down to 1. They're going to go away, okay, and just leave me with that 1b there. And that's what I want. I want that 1b. So these go away and leave me with b. And then don't forget, if you do it to one side, you have to do it to the other. I'm going to erase this and move it over a little bit because we're going to need some space here. All right, so that means over here, we are also multiplying by 5 over 2. When I do that and I multiply across, I get 100 over 2. All right, and then I can simplify that by dividing by 2 here. And when I do that, I get 50 over 1, which is the same as just 50. So the fractions are a little trickier, I will admit. However, you just have to remember, my whole goal is to isolate that variable. My whole goal is to get that letter by itself. And the way that I do it is to use the opposite operation. And so how do I get rid of a fraction? Well, I have to multiply it by that fraction flipped upside down, by the reciprocal. And when I do that, it cancels everything out and leaves me with that letter, and I can then figure out what the other side is, because remember, if you do it to one side, you got to do it to the other. All right, this was a quick little tutoring video on how to solve multiplying and dividing equations. I hope this cleared up any confusion that you may have had about doing these types of things. Remember that you can have negatives, positives, whole numbers, decimals, fractions in these types of equations. Anything is possible, but all you have to do is you do the same thing to each side, and you're using the opposite operation to do this. All right, I hope this helps. I'll talk to you later. Bye.